All right, let me show you how to solve some absolute value inequalities. Now, we've looked at absolute value in a couple of different ways. The first way is by looking at absolute value as a distance. So when we have absolute value of x minus 5 is less than 7, that means the distance between x and 5 is less than 7. Right? So think about the first part, that distance between x and 5. That means if we found 5, we could either go out this far or this far and find our two x's. All right? Well, what should that distance be? It has to be less than 7. So we're going to go less than 7 units away. All right? So if I went out here 7 units, 5 plus 7, that would make this number 12. All right? Now, all of my x's have to be less than that. So it can't be at 12, but it could be right up next to 12. It could be at 11, the distance between 11 and 5, that's less than 7. Or it could be at 8. The distance between 5 and 8 is 3, that's less than 7. So it can be all of these numbers in between here. Same thing when we go to the left. I want the distance between x and 5 to be less than 7. So if I went out 7 units, I would be down here at -2. And I want the distance between -2 and 5 to be less than 7. So it can't be at -2, but it can be all those numbers that are closer to 5. So we're really talking about this situation. To clean this up for you, look at all of our solutions. All of our solutions are what's in red here. All those numbers between -2 and 12. So in interval notation, that'd be from -2 to 12. And we're not going to equal either of them. In standard notation, as a compound inequality, we'd go from -2 is less than x, which is less than 12. Looking at an absolute value as distance really is slick once you get the hang of it. In a minute, I'll show you how to do it algebraically. But let's do a couple more where we look at this in terms of distance. If I have absolute value of x plus 8 is less than 5, remember that means that I have the distance has to be less than 5. And the distance between x and not 8, but -8. Because remember, we have to subtract. So if we were to find -8, that's going to be in the middle. Then I'm going to go out a certain distance to find my x's. They're going to be here and here. Well, where are those two numbers? That distance has to be less than 5 units away. So if I were to start at -8 and add 5 units, this x would be at -3. And we want the distance to be less than 5. So all of these distances that are closer to that -8. Okay. On the other side, if I were to go out 5 units, -8 minus 5 brings us to -13. That's 5 units away. We want that distance to be less than 5 units away. So all of these numbers that are closer to that -8. Then, when we look at our picture, get rid of all the extra stuff. This is our solution. We're saying that -13 is less than x, which is less than -3. In interval notation, that would be -13, -3, and parentheses on each side. Let's try one more where we look at it in terms of distance. Absolute value of x minus 13 is greater than or equal to 11. So we got the distance is greater than or equal to 11. And the distance between what? Between x and 13. So if we found 13, we're going to go out to find our x's. Right? Those x's are going to be a certain distance away. Right? That distance has to be greater than or equal to 11. So the distance has to be 11 units away. 13 plus 11 gets us to 24. But 24 is, that is exactly 11 units away. Right? I want all those numbers that could have a distance that's even further away. So I'm talking about all of these numbers that are out here, right? A million, 200 billion, it doesn't matter. But all those numbers that are to the right of 24. On the other side, that distance has to be greater than or equal to 11. So we go 11 units away. 13 minus 11 brings us to 2. Right? That would be exactly 11 units away. But we want that distance to be greater than or equal to 11. So we can go even further away, all of these numbers that are out here. When we clean up our picture, we don't really need this stuff. This is what our compound inequality looks like. On the left, I have all my x's have to be less than or equal to 2. Or we could have all of our x's being greater than or equal to 24. If we were to write this in interval notation, we're going from negative infinity to 2. It can equal 2, cannot equal negative infinity. And here we're going from 24 to positive infinity. Can't equal infinity, but can equal 24. And since this is a union, we would use this U. Not a U like this, just this U shape. Now, I'm sure you're wondering, how can I do this algebraically? I don't want to have to draw a picture every time. Well, I'm going to show you the long way first, and then I'm going to show you how we can condense it. First of all, we have to use the piecewise definition for absolute value, right? Now, that piecewise definition for the absolute value of x minus 5 would be absolute value of x minus 5 is x minus 5 if x is greater than 5 or equal to 5. Or it's the opposite of x minus 5 if x is less than 5. Right? Because if we had a number that's bigger than 5, like 10 minus 5 is 5, that's already positive, so it would stay positive. If we had a number that's less than 5, like 0 minus 5 is negative 5, absolute value would have to make it positive, so we take the opposite of it. That's where the two pieces of the piecewise definition come in. Notice I left a space in there because now that we're dealing with an inequality, I'm just going to put in less than 7 on each of them. So we have two of these inequalities that we can solve. The first one being x minus 5 is less than 7. So we add 5 to both sides. And x would be less than 12. For the second inequality, we have the opposite of x minus 5 is less than 7. To solve it, we're going to divide by negative 1 to get rid of this negative. Since we divided by a negative number, we have to switch the inequality, and 7 divided by negative 1 is negative 7. Now we add 5 to both sides, and x is greater than negative 2. So we have these two solutions here. X is greater than negative 2, and x is less than 12. If we were to graph that, to just kind of take a peek, what our solution is, here's negative 2, here's 12. We have to be less than 12, greater than negative 2. So we're talking about all of those numbers that are in between there. Notice again, we are talking about an absolute value being less than 7. So a distance being less than 7. So if we went the distance from the middle, we want all those x's that are less than 7 units away. So they have to be very close to this middle. That's why we're talking about this intersection. All the numbers are in between these two endpoints, but not outside of it. Now, you might be looking at this and thinking, that sure is a lot of work. I'd really like to be able to clean this up quite a bit. Well, looking through the work that we just did, there is a couple steps that are going to happen all the time. Like when we go through the first part from x minus 5 is less than 7, we get to this spot here. Right, that's actually just where we started, is x minus 5 is less than 7. When I get through my work for the second part, I do get to this spot where we have another x minus 5. It's just that x minus 5 was now greater than negative 7. Recognizing that, and that is going to happen every time, we can rewrite this inequality when we get rid of the absolute values, is that there's part of this that is going to look exactly like it looks, just without the absolute values. That x minus 5 is less than 7. Right? But from what I have in green, x minus 5 being greater than negative 7, well, I could write this as a compound inequality greater than negative 7. And getting to this first step right away, now we have this compound inequality that's a lot easier to solve. To get x alone, I would want to add 5. So whatever I do to one side, I'm going to do to all three sides. So I'm going to add 5 and add 5. On the left, we'll have negative 2 is less than x, and on the right, less than 12. Right? And then that works a lot quicker. Let's try that again. Now we have the absolute value of x minus 13 is greater than 11. To get rid of the absolute value, we're going to want to split it into two inequalities. X minus 13 is greater than or equal to 11. You know, one of them looks exactly the same. And if I try to do that exact same thing that I did before, then that would mean I have a negative 11 over here, but instead of x minus 13 being greater, it has to be less than. And we don't have compound inequalities that look like this with greater thans in there. All right, so recognizing that, oops, that notationally doesn't look right. You might not recognize that, but thinking about it as distance. I have a distance is greater than 11, so, all right, so I'm going to go here and go out a certain distance, and I want all my answers to be even further out. Right? So I would go out, and all my answers are even further out. Right? So we have this kind of a compound inequality where there are two separate inequalities, the union, not the intersection. So when I write my two inequalities, I get rid of the absolute value, and one of them looks exactly the same. Recognizing that distance is greater means a union. I'm going to have an or situation. And now, instead of greater than, it'll be less than or equal to negative 11. All right, so one of them's positive, one of them's negative. And now just solve each of them. Add 13 to both sides. And we have x is greater than or equal to 24. Or add 13 to both sides. X is less than or equal to 2. Graphically, here's 24. And we want all the answers that are greater than 24. Here's 2. We want all the answers that are less than or equal to 2. Let's try one more. I'm going to break it into two inequalities. The first one looks exactly the same. X plus 11 is less than 20. If you're uncertain about, I don't know if I can make this an intersection or a union, then just separate it into two inequalities. X plus 11 is less than 20, and the other one is completely opposite. So instead of less than, it's greater than. Instead of 20, it's negative 20. And solve each of them. I'm going to subtract 11 from both sides. Over here, I'm going to subtract 11 from both sides. X is less than 9. And over here, x is greater than negative 31. Then use your graph to kind of help you out. So I have x is less than 9 and greater than negative 31. Greater than 31, less than 9. That's what our inequality looks like. So we should write it as an intersection like that. If you wanted to use interval notation, since it can't equal either endpoint, we would just use parentheses.